Hey, Algebra 1. Today we are doing 4.2, which is patterns and linear functions. All right. So our objective for the day is to identify and represent patterns that describe linear functions. And we're just going to start out with some pretty simple definitions of some things that I'm sure you've heard before. All right. So the first one we have is we have dependent variable. Okay, which is right there. It's highlighted already for you, but it's super light on here, so thought I'd just highlight it again. The dependent variable changes its response to another variable, which is the independent variable. That is what they define those two as. All right. The way that I prefer to remember it, and again, I'm sure you've heard these terms before, so it's totally up to you how you remember which is which. But I just always say the independent, it's kind of in the definition of the word itself, right? Independent just means that it is by itself, right? So it will affect the dependent variable, right? Okay, so just like if you're talking about your, I don't know, I guess your own life, being like, yeah, Mom, I'm independent, I don't need you. That means you can do it on your own. And don't say that to your mom; she'll stop cooking you meals. So that's independent, and then dependent, you depend on something else. Same thing with the variable, right? So you guys are all dependent upon your families to pay the bills and whatnot. So the dependent just depends on the independent. Okay. Again, I'm sure you've seen these definitions before. So hopefully I didn't completely waste your time, but just a little refresher there of what the independent and dependent variables are. All right, values that are that come from the independent variable, those are your inputs, okay, and then values of the dependent variable are outputs. All right, so just make sure you understand those, and we're just going to go ahead and move on now. All right, so problem one, they have representing a geometric relationship. Okay, they've got a bunch of rectangles here. And so it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So it asks you to represent 4 different ways. Okay. So you can see pictures and just kind of how they work. So they're adding on a rectangle each time, and then the perimeter goes up each time. Okay. On step 1, you can see down here they went ahead. Whoops, I didn't mean to use the highlighter, but they went ahead and did a table. All right. And you can look at their table really quick. They let X be the number of rectangles. All right. That would be your input. Okay, so your input. So X equals input. It's also the independent variable. All right. And then Y is going to be your output. And that is your dependent variable. All right. For their dependent variable, they have the perimeter. Okay. Because your perimeter is going to be dependent or depend on the number of rectangles that you have. Okay, and then after that, they give you an ordered pair. All right, an ordered pair is always written as X, comma, Y in parentheses. Okay, and that is this column right here. All right, so you can see with the perimeter with Y, we've got 2 times however many rectangles are there for each one. And then we've also got 2 times the length or the height, I guess, of these rectangles up here, all right, which is 6, okay? And then, yeah, so that's their output each time, okay? So for step 2, they say look for a pattern in the table, describe the pattern in words so you can write an equation to represent the relationship. Okay, so they say multiply the number of rectangles in each figure by 2 to get the total length of the top and bottom sides of the combined figure. Then add 2 times 6, which can be simplified as 12, for the total length of the left and right sides of the combined figure to get the entire perimeter. Okay, so basically they use that really long, wordy, lengthy jumble of words, and they come up with this equation right here, the y equals 2x plus 12, okay? So that's your equation you want. All right, and then finally for step 3, you're going to use the table to make a graph. All right, so with the graph, you can see a pattern that is formed by a relationship between the number of rectangles and the perimeter of the combined figure. You can see that right here. So you can see the pattern is that it's slowly rising up and to the right on that graph. Okay, so hopefully you have a grip on what they're doing there. Go ahead and try out 1A here. All right, so it's the same exact problem for the most part. It's just different figures, different shapes, which means you're also going to have a different perimeter, okay, and a different equation as well. So go ahead and give that one a try, and then after you've tried it, you can resume the video, and we'll keep going. All right, once you've finished that, we're at the bottom of page 241. We've got a couple more terms. All right, so you can describe the relationship in problem 1, which was the rectangle one, by saying that the perimeter is a function of the number of rectangles. All right, so a function is a relationship that pairs each input value with exactly one output value. Okay, that's going to be really important going forward. Okay, we're going to do a lot of stuff with functions. Okay, and then the next paragraph, it says you have seen that one way to represent a function is with a graph. A linear function is a function whose graph is a non-vertical line or part of a non-vertical line. Okay, so just to recall, a line is going to be straight, so it's just going to go one direction the entire way. So moving on to problem 2, we're going to use that definition of a linear function, and we're going to represent one. So we have a photography problem, so if you're into photography, this is for you. The table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. All right. So you can see here they've already got a table for us. Again, I didn't mean to highlight, but here we are. I'll go ahead and erase that. And then we have down here the amount of memory. So this is here. Left is uniquely determined by the number X of photos you take. All right. You can see this in the table above where each input value X corresponds to exactly one output value of Y. All right. So Y is a function of X. Okay. So because there's one Y for every X and no more than one Y for every X, it's going to be a function. Okay. To describe this relationship, look at how Y changes for each change in X in the table below. Okay, so you can see when you look at the table, for each value of X, we're going up 1. I've got to get this highlighter off. I am doing horrible with that today. Sorry, guys. So we get plus 1 every time we take a photo because you're taking one photo each time. Okay, and then your memory, every time you take a photo, goes down 3. Okay, that decrease of your memory, or the Y, is dependent on the increase of your X or your number of photos here. Okay. So they put an equation here to represent that. We have y equals 512 minus 3x. Okay. So where this comes from is y is always the independent variable. Okay, so we are trying to figure out what it equals. Okay, so that's going to be alone on one side, and then on the other side, we start at 512, which is why that is alone by itself right there. And then we're also subtracting 3 for every x that we take, or every photo that we take represented by x. Okay, we don't know what this number x is, which is why obviously it's the variable there. Okay, so once you've got this down and understood, go ahead and try out 2A here. All right, and then once you have finished that, that is it for the video. So I will see you guys in class.